The question I posed about this, theoretically, what would you do if I said, okay, instead of 10, 20, and 40, I divided this up where we've got 10, 12, 14, 16, 18, 20, there's 30. So I've got a bunch of intervals here, changing by 2, 10, 12, 14, etc., by even numbers, right? If I asked you to do the same thing, you would have, well, between 10 and 40, the difference is 30. You're dividing it in intervals of length 2, so there are 15 trapezoids involved. Okay? And if you count the number of points I did here and add 1 or subtract 1, you'll find that there are 15. Now, you could take your calculator and punch these in, right? And find all the points. Okay? What shape do you think would emerge if you did that, if you graph these? Remember, you're evaluating this function, right?
Sorry, it would be what parable?
Parabola.
Parable.
Where would the vertex of that parabola be?
It would be at 20. Or I'm guessing it would be right around 20.
Well, now, parabola is symmetric about its axis of symmetry, right?
100 because it's 0.
Well, wait.
BC,
If the axis of symmetry was here,
yeah.
well, is that an axis of symmetry for these 3 points?
Yeah.
Yeah.
No, it's not. It would be.
This point's too far out that way. That's just the same height as this one, but it's too far away. So where do you think the axis of symmetry would be? Well, we don't need to.
25.
Okay, that's probably a pretty good guess. Maybe over this way a little bit, right? Because this thing has to have time to come down to its minimum and then turn around. So the axis of symmetry has to be, okay? Now, was 25 a guess, or did you figure that out?
I just added 10 and 40.
Yeah, if it's going to be symmetric, it's going to have to be halfway between this and this, right?
Yeah.
Halfway between this and this is 25, so there it is. Okay. That's just a side note, okay? Now, because you brought up parabolas, originally I thought I'd mention, and we know that is going to be a parabola, although you probably don't know how to prove that. You will. Rather than sitting down and doing this with a calculator and figuring everything out, which would take you probably a half hour, okay? You could put this into Excel, put these parameters in 3 cells and use cell references and just set the thing up and drag it down for 15 units, okay? You already have you already know how to do that. So if you can do that, then you can start investigating these things and you can get the information here in a table and make good use of it. So that's one thing we want to be able to do. Okay? Another thing relevant to this, if you have 3 points, you can get 3 simultaneous equations for A, B, and C, right? Okay, we've done that. You've seen how to do that. How do you solve those 3 simultaneous equations? Well, you can do it by elimination, right? The easier way to do it is to use a matrix, okay? And to just use the inverse of the matrix. So if you get the right matrix, well, we'll see how to do that. That's like a 2-step process using Wolfram alpha, and you don't have to solve simultaneous equations. Now, a lot of the data that you've been taking would require that you plug in to a quadratic and solve the 3 equations, okay? You can do that in about 1 minute per item using Wolfram alpha. It's going to take you 10 minutes a problem to do it by elimination and check it, okay? So, and it's very easy, much easier than most of what we did yesterday. So we will be going to the computer lab and learning how to set this up and get the information on one of these graphs. And tomorrow we'll talk about how you interpret this, okay, in terms of some of the examples that we've already seen. Okay, So that's one thing I wanted to mention.